In this exercise, we're going to look at finding the rules for cubics given perhaps information or a graph. Now let's just quickly look at these rules. If you can recall, when we were doing quadratics, we did similar sorts of stuff when we had to come up with the quadratic equation. And depending on what information was given to you or how it was presented would depend on what rule you might use. So this first one up here is when you have got all of the x-intercepts. That would be a really good rule to use. For the second one there, that is when you have one of your x-intercepts touching. So you have a repeated x-intercept, if you like. So that means that you'll only have two x-intercepts. Of course, you need other information, so you need another point as well to be able to work out all of these. This one is when we've got that point of inflection form, which we looked at right at the beginning of sketching cubics. So you have that point of inflection, like turning point form for a quadratic. And this one is just when you have any 4 points, and we will use the calculator to be able to work that one out rather than use simultaneous. So let's have a look at the first example here. We are going to find the cubic equation for the following graph. So what information do you have? Okay, well, you have two x-intercepts. You have x equal to -1 and you have x equal to 2. Now this one here is touching the x-axis, which means it's going to be a squared factor. So far you've got x plus 1 and you have x minus 2 all squared. I would suggest that then this would be the best format to use. So let's use that. Now, what other point do we have here? We also have this point 3, 2. That will help us get our a value out. So using the rule y equal to a outside of x minus b, x minus c squared. Now you don't have to use the rule. If you know what you're doing here, you can say, okay, I need my dilation factor. I've got one factor and my repeated factor is that one. So the only thing that I now need to find is that value of a, and I'm going to use 3, 2. When x is 3, y is equal to 2. So what do you get? You get 2 is equal to a outside of 3 plus 1, which is 4, 3 minus 2, which is 1. Okay, and when you tidy all that up, you get a is equal to 2 on 4 or 1/2. So therefore, what is my equation here? Y is equal to, okay, we found that a was 1/2, so it's 1/2 outside of x plus 1, x minus 2 all squared. Again, that was where my graph touched my x-axis. That's why it is a squared term. So in this example here, the graph appears to be in a form where we've got a point of inflection. There's our point of inflection. We've only got one x-intercept. So our point of inflection, hopefully you can see that as being -1 and 2. So I'm going to use that format, y equal to a outside of x minus h squared. Sorry, that should be cubed because we're doing cubics plus k. And I'm going to substitute in my point of inflection, which is y equal to a. So x plus 1, because it was minus h, plus 2. Now, the only other bit of information I need to find there is my a value. So I'm going to use the other point that I know in that graph, which is 1, -2. So let's substitute that in, and I get -2 is equal to a outside of 1 plus 1, which is 2 cubed, plus 2. Bring the 2 across, -4 equals 8a minus 4 on 8 is minus a half is equal to a. So therefore, what is the equation for my graph? It would be y equal to minus a half x plus 1 or cubed plus 2. So that is in point of inflection form. Now the last example there would be pretty difficult to work out using simultaneous equations because there's 4 unknowns. Remember what this talks about. F1 is equal to f of 1 equal to 0 means that when x is 1, y is 0. The next one would be when x is 2, y is minus 7. When x is 4, y is 27. When x is 5, y is 80. And then you would substitute each one of them in separately and come up with 4 different equations. So we don't need to be able to do that at this point. What we do want to be able to do is use our calculator to find the values. So you can see in the bottom bit here how to put it into your calculator, and this is for TI of course. So when we put that into our calculator using simultaneous equations on our calculator, you end up with A equal to 1, B equal to 1, C equal to minus 17, and D equal to 15. Obviously a lot easier than having to do all the working out, but we do need to be able to use our calculator for this sort of work.